Stephen William Hawking, born January 8, 1942, died on March 14, 2018, was an English theoretical physicist, cosmologist, and author who, at the time of his death, was director of research at the Center for Theoretical Cosmology at the University of Cambridge. Between 1979 and 2009, he was the location professor of mathematics at the University of Cambridge, widely viewed as one of the most prestigious academic posts in the world. So, he was also known for Hawking radiation, is a theoretical thermal blackbody radiation released outside a black hole's event horizon. This is counterintuitive because once ordinary electromagnetic radiation is inside the event horizon, it cannot escape. It is named after the physicist Stephen Hawking, who developed a theoretical argument for physics in 1974. Hawking radiation is predicted to be extremely faint and is many orders of magnitude below the current best telescope's detecting ability. Hawking radiation reduces the mass and rotational energy of black holes and is therefore also theorized to cause black hole evaporation. Because of this, black holes that do not gain mass through other means are expected to shrink and ultimately vanish. For all but the smallest black holes, this would happen extremely slowly. The radiation temperature is inversely proportional to the black hole's mass. So, micro black holes are predicted to be larger emitters of radiation than larger black holes and should dissipate faster per their mass. As such, if small black holes exist such as permitted by the hypothesis of primordial black holes, they ought to die the faster the smaller they shrink, leading to a final cataclysm of high energy radiation alone. Such radiation surges have not been detected as of yet. So the other one is the black hole information paradox. It's a puzzle that appears when the predictions of quantum mechanics and general relativity are combined. The theory of general relativity predicts the existence of black holes that are regions of spacetime from which nothing, not even light, can escape. In the 1970s, Stephen Hawking applied a semi-classical approach of quantum field theory in curved spacetime to such system and found that an isolated black hole would emit a form of radiation called Hawking radiation. Hawking also argued that the detailed form of the radiation would be independent of the initial state of the black hole and would depend only on its mass, electric charge, and angular momentum. So, Jane Bearable Hawking Jones, born on March 29, 1944, is an English author and teacher. She was married to Stephen Hawking for 30 years. So, the scientific career of Stephen Hawking was the field of general relativity, also known as the general theory of relativity and Einstein's theory of gravity. It's a geometric theory of gravitation published by Albert Einstein in 1915, and it is the current description of gravitation in modern physics. General relativity generalizes special relativity and refines Newton's law of universal gravitation, providing a unified description of gravity as a geometric property of space and time or four-dimensional spacetime. In particular, the curvature of spacetime is directly related to the energy and momentum of whatever matter radiation are present. The relation is specified by the Einstein field equation, a system of second-order partial and differential equations. Pixie, be quiet. I have a reporting to do. Kiss. So the other one is quantum gravity. Quantum gravity is a field of theoretical physics that seeks to describe gravity according to the principles of quantum mechanics. It deals with environments in which neither gravitational nor quantum effects can be ignored, such as in the vicinity of black holes or similar compact astrophysical objects, such as neutron stars, as well as in the early stages of the universe moments after the Big Bang. The field of quantum gravity is actively developing, and theories are exploring a variety of approaches to the problem of quantum gravity, the most popular being M-theory and loop quantum gravity. All of these are approaches aimed to describe the quantum behavior of the gravitational field, which does not necessarily include unifying all fundamentals interaction into a single mathematical framework. However, many approaches to quantum gravity, such as theory, try to develop a framework that describes all fundamental forces. Such a theory is often referred to as a theory of everything. Some of the approaches, such as loop quantum gravity, make no such attempt. Instead, they make an effort to quantize the gravitational field, while it is kept separate from the other forces. Other lesser known but no less important theories include causal dynamic triangulation, non-communicant geometry, and twistor theory.